from FCI, and we're at 11 o'clock exactly. So Art, you can go ahead.
All right, thanks again, Matt. Appreciate everybody taking the time today to attend this webinar. Hopefully everybody's staying safe during these unprecedented times. One of the things we want to look at here today is the mass flow metering offering of FCI. In addition to many manufacturers, you have choices to work with in their products. Within FCI ourselves, we have a pretty extensive offering. When you look at the way we built our product line, we're really looking at the fewer featured, lower end, more economical devices like the ST50, all the way up through, the MT100 series, which is a very high featured multi-point configuration for larger systems. And you can see here in the middle, our new mid-range product, which was released, a little bit over 2 years ago, is the ST80. So, going to break it down into a few groups. The first one is single point flow meters, and what we mean by single point is it's just one sensor in this is the system. And there's a couple different styles. You have an insertion type, which allows you to utilize the existing piping and ductwork. And then you have what we refer to as inline, some might look at as a spool design, where the sensor is, installed in a spool piece and then calibrated in that fashion. For insertion styles, we actually have 8 different models, actually 9 different models if you consider the 2 variations of the ST51, 51A. These are for larger than 2-inch line sizes, 2.5 up to, as large as you need to go. Just recognize that as you get to a certain line size, if you only have 1 point in it, you have some inaccuracies, but you can use them in the very large line sizes, 30-inch ducts, pipes. Then we have, 4 variations of the inline style, and these are 2-inch and smaller lines, again, going from the more economical units from the ST75 up through the versions with the 80L, 100L, where you have a lot more feature sets than you do in the economical products. As far as the inline models go, we look at going to this style for a few reasons. One of them primarily is that by calibrating the device in that spool piece, it really ensures overall accuracy in the field. The reasons for this impact on accuracy, the first thing you have is rotational effect. So for smaller line sizes, if I have more rotational effect, it's going to introduce a little bit larger error than it would on the larger line sizes. The next one we deal with is the insertion depth. So if I'm off a little bit on the insertion compared to where it was, positioned at the factory in calibration, again, introducing larger errors, And then you have some sensor blockage, the sensor itself, in a small line size creates blockage, which creates, a less than ideal flow pattern, also creates some additional pressure loss that none of us want to deal with. There are some exceptions that we've had with the 2-inch lines, primarily going to an insertion style with the more economical units. But, a limitation on there as far as the flow range capability compared to, the data, the application capability in 2-inch and larger lines. Process connections, a range of options, from compression fittings and packing glands that allow you some adjustability in the field. Packing gland giving you the added option if you're going to be, removing an instrument on a regular basis for any type of, preventative maintenance. It's the most flexible there. Flange types, you have to look at if you go to a fixed flange, now you're paying more attention to your installation details. So compression fittings and packing glands give you a little bit of leeway that you don't have with a fixed installation. On the elements itself, a few key features. You've got a directional arrow to, show the orientation of it. That way our sensors are perpendicular to the flow, and, we're installed in a way that the flow is matching the way it went into the stand at our factory. We mass balance those flow sensors, but, you still are looking at, some minor differences if that flow direction is reversed. Doesn't mean it's not going to give you a good reading. It just might introduce a small amount of inaccuracy. The next part to help simplify installation is a depth gauge. So we etch this depth gauge onto it, and by taking the proper measurements of your piping, your process connection and such, you can help insert that insertion style meter to the point where it's either a 1/2 inch or 1/4 inch beyond center line, depending upon the product. And then finally, a feature that's very unique to FCI is captive flow elements. If you look at the sensor itself, you see that flared edge at the end of the extension prior to the sensor. That flared edge is captured by the compression fitting packing gland, even a thread-on flange, to the point that if you're in a higher pressure system, you don't have to worry about that flow element coming completely free of the compression fitting once you've loosened it to, remove for preventative maintenance. This gives you a little idea of the installation measurements that we talked about, being, again, past center line. The insertion length is going to be based on how you're connecting to the process, whether it's a threadlet, standoff with a flange, and the ability to get that precisely centered using that depth gauge markings. Another area to consider is when you look at going with a hot tap, isolation ball valve type arrangement. So again, you can do some preventative maintenance, without shutting down the process. You've really got to go in and take into account that additional length of the ball valve, how it's being installed, whether it's flanged, whether you have a 2-inch nipple on the pipe or a 4-inch nipple on the pipe. We really need to take into account those dimensions when coming up with the right insertion length. So we're at the center line plus, 1/2 inch, 1/4 inch, depending upon the product. Not only do we have an extensive line of flow meters, we have an extensive line of sensor options that are geared towards the applications. For the longest time, we've had what we refer to as an FP sensor and an S sensor, which have been the mainstay of our product offering. The F-style sensor, a little bit thinner thermal well, gives you a little bit better response time than the S-style sensor, which is thicker thermal wells and more designed for when you have some H2S, some other corrosive medias that might be slow acting. Gives you a little bit more mass to deal with in that thermal well itself before there's concerns about replacement. For the thinner thermal well items, you can see they've got protective cages around them. The FPC is a very unique sensor within the industry. It was designed specifically for compressed air, higher pressure applications. We noticed that in certain conditions, there was a little bit of a decline in the reading at these higher pressure gases. So this sensor has this little conditioning plate built into it that's on the back side of the flow direction. And this basically just ensures we get good heat transfer between the heated RTD and the media flowing. And then recently we introduced one of our best kept secrets that we've been doing as specials, but we've standardized on it now and made it a standard offering, is this wet gas sensor. Whoops, sorry. This wet gas sensor, which is designed, really as a mechanical knockout. it's not really set up for dual phase, with, but it is a way that if you've got some moisture in your process, one way of handling that issue. We'll talk about it a little bit more later on here. So with these all these different sensor types, we've got some general recommendations. Doesn't mean that you can't use a sensor in a application that it's rated good or not recommended, because sometimes conditions still say, hey, this is probably the best suited sensor for it. But we give you a little bit of a guideline, whether your process is dirty, whether it's got moisture in it, pulsation. Again, that FPC sensor handles pulsation very well. Response times. So just a guideline you can find in a lot of our manuals to brochures to help you figure out what might be best suited. So with that, there are some limitations. For a lot of our models, the higher end models, the ST80 to 100, you can select which type of head you want based on the application. But for the lower end models, the 50s, the 51s, based on your process conditions, you're going to either get that FP head or the FPC head. When you go above 50 pounds or so, we're going to automatically give you that FPC head. For the wet gas sensor, for the ST80 that we introduced a couple years ago, that is, a standard feature. It is optional on the ST100. The lower end units, this is not an option, just based on the construction and everything. It's, not designed to fit onto the smaller flow element of the ST5051. Again, we want to look at the wet gas sensors are really not suited for dual phase. So we're looking at things that are lower moisture content. Maybe you've got entrained moisture in the 5% area. Nothing to exceed 10%. Above that, it's really a dual phase measurement, which thermal should probably not be considered as a solution. So details of that wet gas sensor. You look at it, a standard FP sensor, we've got the thinner thermal wells. Well, really what we're looking at is just doing a mechanical knockout of the moisture in the line. We're taking a approach that, leaves the sensor at its normal temperatures, as far as heating the RTD. If you look in the upper left here, you see the inlet side of it. In the lower left, there's a screen in there to help knock out some of the entrained moisture. And then you look on the right, upper right, that's the outlet of the sensor, and there's actually a small, barrier between the inlet and the outlet side, and with a very small gap, and that helps knock out more moisture from your process gas. Then you can see, the basic configuration inlet outlet here down on the lower right. One thing to keep in mind is this wet gas sensor is really more of a solution for a known instance where you've had technologies that have not been able to work properly because of the moisture that's entrained in the gas, or you want to use it as a little bit of security if you're dealing with an application like a biogas or a landfill digester gas type application, something that typically generates moisture. You don't have something in your system to knock that moisture out prior to your metering point, which would really be ideal, but a lot of times that's not feasible. So it gives you this solution. The other side of it is, this is something that's got to be manufactured at the time the unit's sold. It's not something that we can add on after the fact, just based on the way that shroud is mounted to the sensor, and everything is calibrated for that knockout. So traditionally, we've had other ways to address wet gas as just your mounting orientations, and this would apply to any of our meters. You know, for moisture, we prefer to be in that lower half of the pipe, whether it's side 45 or bottom. When you have it on the top, all you're doing is giving a flow path for any condensation that might form on the wall of the pipe to flow down to the sensor itself. And that's a situation we want to avoid. For the entrained moisture, for the wet gas sensor, we're still looking at being in that lower half of the pipe. You know, in this case, bottom mounted would probably not be the most recommended because there's some tiny slots in that sensor head, that shroud, to drop the moisture out of it as well. One last item on the wet gas sensor is, you know, comparing it to a unshrouded sensor. So just a quick show here as we introduce moisture in a little test stand. The red line is typically what you would see from a standard constant power driven flow meter. You know, as we introduce more moisture, the cooling effect of that moisture versus the gas is causing us to get this false high spiking reading. And, you know, depending upon the content, it can be quite large. So in comparison, in the same conditions with the wet gas sensor, now we're looking at the blue line, and you can see it remains very steady. You know, one of the things you're looking at now is just, you know, you're still seeing some water vapor, so there's a little bit of a change, but it's not large compared to what you would find with an unshrouded sensor. So Matt, I think that might be a good breaking point if there's any questions.
Yeah, Art, there's none yet, so you can continue.
All right, plowing along. Okay. So let's look next at inline process connections availability. We have, you know, some, again, on the economical side, we have things like standard MPT T's, tube T's, and then we get into flanged and threaded versions of it, you know, and again, with these spool pieces, now we're dealing with actually providing part of the process piping. The other area we have unique to FCI is what we call a Vortab flow conditioner. So with a few of these models, the 75Vs, the ADL 100L, we have the ability to put in this integral flow conditioner as part of that spool piece design, and there's some reasons for doing that. When you look at a fully developed flow profile, because that's the condition that we're calibrating our instruments to, you know, most manufacturers are calibrating for these nice fully developed flow profiles. So depending upon where we're at in the Reynolds number range, we're either, you know, a laminar flow where we've got the nice fully developed bullet, or we in the turbulent side where we flattened out quite a bit. And then the other area is if we go with that Vortab flow conditioner, we create that very repeatable flat profile that, you know, the instrument's calibrated to, because we're calibrating the spool piece. And one of the main drivers for doing that is, you know, with these smaller line sizes, a lot of times we're starting to get into the Reynolds number transitional zone. And when you get into that zone, you know, we're in an area where we really have a nonlinearity situation occurring, because, you know, the sensor really is not seeing laminar nor turbulent flow. So with that, you know, we have this fishhook effect. If you look at the blue line, if you were to go through that Reynolds number transitional zone, you kind of get that fishhook and it, you know, that nonlinearity. And that nonlinearity can be as much as 10%. So when we run your application, we recognize we're in that transitional zone. You know, one option we have is to go with that Vortab integral to the flow element, and that gives you a smoothed out, you know, fully linear output. You know, the Vortab itself doesn't create a laminar or turbulent condition. it's very repeatable across the entire flow range, and that's how the meter's calibrated. A lot of basic things that you see, integral versus remote configurations, you know, integral enclosures, you know, things to look at on the Economical series. That flow element is threaded into the enclosure and there's no adjustability to it. Whereas on the newer units, the higher end ones, we actually have a locking nut here where you can rotate that enclosure 180 degrees depending upon, you know, where it needs to be oriented. So as a result, that one's very flexible with regards to selecting a flow direction and orientation. With the integral units on the 50, 75s, you know, we really need to pay attention to this direction chart that we provided so we make sure it's oriented properly, you know, top, you know, side, vertical up, horizontal, left to right, things of that nature, because you got to keep in mind that if you order a unit with a display, you know, how am I going to be looking at it? How's the customer going to be looking at it in the field? And if we go with that unit and we've got that orientation incorrect, you know, it's not something that can easily be corrected in the field. Standard enclosure types, you know, available are aluminum, polyester coated. We actually have stainless steel enclosure options on all of our flow meters, the Economical as well as the higher end. You know, kind of a run through on the displays, you know, again, informationally, the ST50 being that very basic model has the most simplified display. It's just 4 digits. You know, it's going to give you a reading. There's going to be a label that tells you the units or multiplier, and it's not something that is changed in the field. From the stepping up, we've got our traditional 2-line display, flow rate, as well as total ice flow or temperature on the second line. And then with the newer units, you have a much larger 2x2 graphical display that's very informational. And there's a couple of versions of this. For the newer released ST80, we have it just a nice display. For an upgrade, as well as the ST100, you actually have the option, you know, on the 80 for these, you know, touch buttons. So you have the ability to do a little configuration and access information in the field. When you look at that display, again, a lot of information here. We have a graphical representation of percentage of flow, flow rate, total ice flow. You always get also the temperature reading. You know, for these units, you have the option to do 2 or more calibration groups depending upon the model. So you'll be able to see which group you're in. If you have more calibrations than one, you can retag it itself. This last line is actually something you can reprogram, give it a tag number, you know, your own application name, and it's backlit. It's a very nice display. The other side of it is when we talked about installation and orientation of the display, not only do you have that mechanical rotation that's available on the 80s and the 100s, since this is a 2x2 square display, you actually can electronically adjust the orientation of that display depending upon, you know, how you're installed, vertical, horizontal. So a lot of features there. Other area we have on the 8100 custom sun shields, the sun shield designed specifically for the model. Not only does it protect the display, but it also gives you fairly easy access to the electronics on the backside, the area where you're going to do your termination of your power, your outputs. Going to the higher end product, one feature it has that kind of sets itself apart is the ability to do this validation self-test. So this is on the 8100s. You know, what we have is internal to the device, there's actually 3 precision resistors, a high, to kind of represent, a low, medium, high setup. It's not any specific flow rate to that particular unit, but it gives us the ability to bypass the sensor itself and check that our electronics are still receiving the right inputs. We're not seeing issues such as drift. With the product, if you've got the HMI, you can actually initiate the self-test in the field without hooking anything up to it. You don't even have to open up the enclosure. Those optical interfaces, can be, accessed through the glass itself. If you've got the ST80 without the buttons, there's a PC software configuration tool that we provide that allows you to run that test on demand, or you can, even schedule these tests on either version to occur at a certain point, daily, weekly, monthly, depending upon your needs. And again, what we're doing is we're swapping in those precision resistors. We're just making sure that we're getting the same reading, or very close to the same reading that we had the day the unit was manufactured. Gives us a reassurance that the unit hasn't drifted. And, you can see the results for it. This test takes about a minute overall, 20 seconds for each point. But again, gives you some confidence that you don't get from a unit that without a validation feature. So when we get into some of our more higher end units, we've got a couple versions that have what we call a VeriCal, which is another validation technique, more extensive than an electronics check. And then we have a version of this we refer to as the STP, which we actually integrate a pressure transducer into it. So what we have is a port in the flow element and a tube that accesses the process pressure that goes up through that flow element. And depending upon features, whether it's just VeriCal, pressure, or both, we tap into that tube. And if you look at the center here, you can see how small that opening is, that gives us access to the process condition. So the way VeriCal is going to differ from the self-test is in a VeriCal mode, we're actually exercising the entire flow meter. This is more of a wet verification. So basically we have, a sonic nozzle, the control valve, and then on the inlet, you're going to want to regulate the pressure to a known value. And based on that, we're creating a very repeatable condition across the flow element. And again, it's not specific to a flow rate, but if, it gives me a measurable, repeatable value, I can compare the day I install it to 6 months down the road, a year down the road, to make sure my meter is giving me similar performance. It's really the ability to have a higher confidence in your meter performance, your readings. Excuse me. So a little bit more detail of that. When you go into this VeriCal mode, you need to be able to isolate it from the process, because we're going to be introducing a gas, and you can use nitrogen, compressed air, whatever gas you want. We use nitrogen at the factory as our baseline, but you can establish your own baseline off of some other media from the day you install it. So this kind of gives you a feel for how it goes together, but you isolate it, run your test, compare it to your prior readings, just to give you that confidence. And again, exercising the entire meter versus just the electronics. The other thing to look at thermal is truly a multivariable device. So with all of our meters, you're getting both flow rate as well as process temperature being measured. The devices have 2 analog outputs, so you can bring both of those process parameters across. In the case of an STP version where we had that pressure transducer, you actually have 3 analog outputs on that model, so you can bring all of that across. So this gives us the capability of, matching up truly to a multivariable pressure transmitter, or the configuration of a differential pressure transmitter with pressure and temperature compensation. But one thing to look at when you see these capabilities, comparing to like an Orifice, for example, from a cost standpoint, everything's fairly even. There's a little bit of an edge for thermal if you look at just basic costs of all the accessories you need to purchase for that. But when you get into, the big savings is going to come in your energy loss, your permanent pressure loss. So when you look at cost of ownership, you've got to take that energy loss into account to really get your true overall costs. And a lot of times I think we don't look at that closely. There's some definite savings from an installation standpoint, from a single process point, but just gives you that overview of the value thermal brings to your measurements, not only in performance, but in overall ownership costs. FCI is very focused on offering you a lot of bus protocols, bus communications capabilities. So with that, we have, options for Heart, Modbus, Field Bus, Profibus, and these are not just add-ons. They're not hockey pucks or some type of interface device. These are fully integrated, protocols, and we've gone through each of the parties to make sure that we're registered. So, with that, you can kind of see the options available for each kind of series here. The low end one, absolutely no options. You're just getting analog outputs. But as you step up, you get a little bit more capability. One area to note is recently we've completed our work on Profibus DP for the ST80 series. That's our most recent product introduction. So we have that added capability there. So we have both versions of Profibus available, depending upon your market needs. So a little bit more generic comparison of the different flavors of FCI meters. Again, ST50 is the low end side of it. 51 gives you a little bit more capability. ST50s really, the calibrations are air and nitrogen, and it's a class 1 Div 2 device. So when you look at some of the greater options here, as we step up, ST51, we can do all gases, and that gets into the biogas, hydrocarbon mixtures. We get the 2-line, we get the Div 1 rating. So now we're into the explosion-proof enclosure ratings all the way around. Stepping up to the ST51A, now I'm getting the bus capabilities, a little bit better temperature capability, can drive the electronics a little bit further, 50 feet to 100 feet. And this is one product where we've actually taken it to Exida and had a FMETA perform. So we know what the failure rate data is for, IEC 61508, 61511. Stepping up from the 51A, which again, that's more of our economical or, better scenario, we go to the ST80 in the group, and quite a bit of difference here. We have flow elements with higher temperature capabilities, flow range capabilities on the stand, the bus capabilities, and we can go up to 1,000 feet between, the flow element and a remote electronics. And that dry check run, the self-validation, and I can actually put 2 different calibration groups in here. If I've got, a process that has some seasonal changes, I can put in a gas mixture for each one of those seasons that I can switch through. If I, switch from, one process to the other, sometimes you'll see people using natural gas. Off season, they might have to back it in with propane. you have the ability to put both calibrations in and use a calibration that's most accurate for your process conditions. And then stepping up from the 80 to the 100, some big changes here. This is our more accurate meter. We're looking at 0.75% of reading. This is kind of a typo, but instead of a 200 to 1 turn down, we can actually do 1,000 to 1. Talked about the analog outputs, the touch buttons. One area we have, it also has an onboard data logging system. So with an SD card, you can store readings if the meter's set up for it through the software. Do up to 5 calibration groups. This comes in a lot of times into play with your flare gas applications. The pressure option, and then the one we'll talk about here a little bit later, a multi-point averaging system where you'd have 2 flow elements averaged into one set of electronics, for making higher accurate measurements in larger lines, or sometimes straight run conditions prevent you from getting there. So another nice break point. Don't know if we've got any questions.
Yes, we do have a question here, Art. And so right now they have a differential pressure measurement on a gas line to a furnace, which struggles to read flow when the furnace is idled. Will this technology allow the reading of both idle and full load gas with a single instrument?
Yeah. One of the big advantages of our technology, thermal technology, is this turn down capability, whether it be 100 to 1 on the basic units or 1,000 to 1 on the higher end units. You have that ability to much broader turn down. Your typical high end differential or multivariable transmitter is going to give you 8 to 1, 14 to 1 turn down, and it kind of limits you as to whether I catch the low end or the high end when I design my system. With that 100 to 1 turn down, we can get as low as a foot per second up to 100 feet per second as far as the velocity range goes. So in a lot of these natural gas applications, the boilers, burners, and such, thermal is going to allow you to really catch both of those conditions, the normal condition as well as that pilot condition.
Thanks, Art.
Not sure if that answers the question.
I think it does. And that's all the questions for now.
Okay. All right. The next part of the FCI family is multi-point thermal flow meters, and touched on it briefly is the need for a multi-point. When we get into larger ducts, larger lines, 20 inches or higher, we start getting into a single point measurement in the center of that duct or pipe is going to lead to some inaccuracies. Now, in some areas, it might be only 1%, but in other areas, as you get into the 30-inch range, you might be talking 5-6% error just by using that single point sensor. So at that point, what we want to do is, look at it from breaking it down cross-sectionally and putting more points into the system, and then averaging all of those points into a single meter reading. So line size is one area to take this approach. The other area might be due to lack of straight run, because the other thing you deal with these large size lines is straight run issues on a common basis. That's a lot of real estate to have to cover. So that we have different approaches with the metering as far as number of points we can put into the system. So one of the first things to look at is this ST102A. Now we're looking at a 2-point averaging system, and from my experience, up to about 40 inches in line size, as far as think a round diameter duct or pipe this is a very good approach to providing you a higher accurate reading in these larger line sizes. It's more economical as well compared to our fully featured device. So you get all those benefits of the ST100 with the ability to improve your accuracy. Now, when you go to the MT100 here, we've got a couple different options. We have the option to use a single point sensor like we saw on the ST102. And with that, we can go 2 to 8 points depending upon the duct size and the accuracy we're trying to achieve. The other area, again, is going to a mass style. This was our more traditional style, a little bit, difficult to deal with at times, because now we're looking at, instead of compression fitting options, packing gland options, we're either a fixed flanged or a 2-inch MPT connection. So given that, you got to really pay more attention to the details of the installation. And with these multi-point probes, these larger ones where we put 2 or more points on the single mast, you also got to be thinking of access, about orientation. Do I have enough room to clear that sensor to get it across the duct or pipe that I'm putting into? So that's kind of the different versions of the MT100. So you'll hear the M for the single mass type sensor and the S for the single point sensors. What makes this one of the most fully featured transmitters we offer is a large color, touch interface for this device, giving us information, again, graphically on our flow rate, temperature as well, sensor status. Depending upon how many sensors we have in the system, we can see if it's still within the range. And over here in the center, I can actually plot things. I can plot my temperature or my flow rate graphically over time. With an option for SEMS, we have the ability to do a system check from the display. Without the SEMS option, you can do it, through the interface. But SEMS is more geared towards the EPA requirement to do some sort of interference and drift check on your meter every 24 hours. So this device has that capability. Just like the other meters, we have a comparison sheet, things that set it apart. ST102A, part of that ST100 series family. Again, we've done some work. We have failure rate data to demonstrate compliance to IEC 61508. Quite a bit difference in accuracy here, the 0.75% of reading. The MT100 is a 1.75% of reading device. So with that, again, that crossover between the ST102 and the MT100 as far as overall accuracy goes comes into play around 40 to 48 inches. At that point, the base accuracy of the 102A is overcome by, we're only 2 points in a large system. Flow range, 1/4 foot per second for the single point sensors, well, actually across the whole range. But the S's, in the 102A, you're able to get up to 1,000 feet per second. Some turndown capabilities. And then feature-wise, again, that SEMS compliance is in the 100s. For the 102A, we still have the ability to do the wet gas sensor as a special. And it's got that data logging capability as well. So some of the highlights here, just for your reference later on, it's with all the different models we have, kind of broken it down into inlines by accuracy reading. The basic units, the lower end units, is really a 2% of reading device with an option for 1%. anything with a Vortab integral to it's going to be a 1%, and then the higher end units are 0.75% of reading. On the L's, the ST80 is a 1% device. Turndown capabilities, 100 to 1. Again, much better than you're going to get from a lot of technologies on the market. But as you go to the higher end units, you're looking at being able to achieve 200 to 1, even 1,000 to 1, depending upon your application requirements. And the last area that really sets thermal apart from other technologies is the ability to do these very low flow applications, from a standpoint of 1 all the way down to a quarter foot per second, and that's critical on applications, such as biogas, landfill gas, things where based on condition, that flow range can vary greatly. Even in your larger boiler applications for large ducts, a lot of times being able to measure down to that quarter foot per second is critical in, managing the efficiencies of your system. As far as IEC 61508 goes, we have gone through a couple different partners, TÜV, Nord, and Exida, to get failure rate data on our products. So if you ever get into a safety instrument system application, please don't hesitate to contact us, and we can see if we have a solution to meet your needs. For microprocessor-based devices, a lot of cases where a SIL1 is a single device. We do have a monitor, which we haven't talked about today. It's got a nonlinear output that reaches SIL2. And then our FLT93 flow switch, which we haven't talked about. It's a purely analog device, and it also is a SIL2, compliant device. So hopefully that gives you a very good overview, at least a starting point of our product offering, the feature sets we bring to you, the capabilities from a bus and output standpoint, how we approach things from a application standpoint, and really driving sensor selection and meter selection to meet your needs. So appreciate everyone's time. Matt, are there any more questions there?
No further questions.